What's up, you guys? Are you guys interested in Neovim? Are you interested in learning Lisp, but you don't want to go down that Emacs rabbit hole? Well, Fennel might be exactly what you're looking for. Now, while I mentioned Fennel in the context of Neovim, Fennel itself is actually completely abstracted from it. In fact, Fennel is just a Lisp that can be compiled to Lua. So because of that, that means that it can be used anywhere that Lua can be used. That includes everything from awesome window manager to LuaKit, which is a web browser, and you can even make games with it with the Love game engine. That's not to mention all the different programs that support scripting with it, like MPV and a ton of other tools that have the ability to extend different features. In fact, the MPV one was actually what I used before my current video editor that I use to actually add timestamps into my videos. Now, because Fennel compiles to Lua, it's actually a really good place to start for those of you that aren't familiar with Lisps. It basically takes the syntax, compiles it to Lua, and you can look at the Lua to understand how it works under the hood. On top of that, the fact that it has a pretty simplified syntax makes it a lot easier to understand than maybe starting with Lua. That being said, Lua is pretty simple as it is, so either place is a good place to start. I just think Fennel is a lot more fun to learn because it gives you a good opportunity to get introduced to Lisp. And if you're thinking you don't have any experience with Lua, though you might have a hard time with Fennel, don't worry. I actually had pretty much no experience with Lua before when I took a look at Fennel for the first time, and I got to grips with it pretty quick. So you're probably wondering, why exactly should I be taking a look at Fennel? Well, the answer is that there's plenty of reasons to take a look at Fennel, but here are some of the ones that introduced me to it and the reasons that I actually stuck around and kept using it. One of the biggest reasons I took a look at Lisps and Fennel in particular was because of the simplified syntax, and you'll see that as we go through the video. The simplified syntax makes getting to grips with things and trying to modify things to work for you pretty simple because it allows you to basically take a look at something, and while at first all the extra parentheses may be confusing, once you actually get used to looking at it, it kind of simplifies the whole thing. You don't have to worry about anything extra, like maybe the order of operations. It's very clear how things break down. People like to say that the actual way that the computer is evaluating things is how Lisps are structured, and you can kind of look at it that way. I'm not going to get too into that because that kind of starts to confuse some people, but the idea of it is that the syntax is very simple. Now, one of the other reasons I started taking a look at it was because Lua itself is kind of nice because it's minimal. It doesn't really have too many syntax features to it, but it does have some things that end up making the code a bit clumsy because they take up a lot of space. For example, the function keyword itself is used in a lot of different places for things like callback functions, which are used a lot in different programs that integrate with Lua, and because of that, it can be really annoying. Versus Fennel uses just the keyword fn, which is obviously much shorter than the whole word function, as well as in Lua itself, it ends functions with the keyword end, versus in Fennel, you would actually just end it with a parentheses. So because of that, it ends up making the code pretty concise. That's not to mention the general way that people like to program with Lisp, where all the parentheses laid off to the side makes the code look terrifying to new people. But once you're used to it, it's pretty simple, and it allows the code to be a lot more concise because it's all compacted together. Now, the next reason I took a look at it is because not only is its syntax Lisp-like, but it also has closure-like structure to it. So because of that, it simplifies a lot of things like keywords. And because Clojure is a bit more of a modern Lisp than the other alternatives, it does a better way of handling different constructs such as dictionaries and arrays, rather than being stuck with just using linked lists like most Lisps do. This is both a benefit and a flaw depending on your perspective on it, but I think it's the best approach for this use case. Much like Lua itself, it is really easy to learn. And because of that, I could probably cover this in its own video really quickly. This is mostly just going to get you guys up on your feet and get started. Maybe in the future, if there's enough demand for it, I'll go a bit deeper into it. Another reason to learn it is it actually introduces you to the concepts of different Lisps. Not super in depth, but it gets you kind of started and it allows you to become a lot more comfortable with it. And then in the future, if you want to work with something like Clojure, Common Lisp, or Scheme, then you'll have a really good starting point. Now, this is probably one of the best things that it has over Lua itself, is its scoping features. It handles scoping much more clearly than you would with Lua itself. That mostly comes from just how it handles things is very similar to other Lisps. And because of that, you don't really run into the whole headache that you get of things constantly changing around you, you having to worry about globally scoped things and jumping around and making sure that nothing's conflicting when you run into an error. It kind of keeps everything very concise, and we'll go into that a bit further on in this video. Another thing I like about it is how it handles tables. For those of you familiar with Lua, tables are basically a combination of an array and a dictionary. And because of that, it does make the syntax a lot more simple, but it does make things a bit confusing when you're jumping back and forth between the two contexts, because sometimes they can look very similar. And so because of that, Fennel adds a bit more constructs to make it clear when you're using an array style table and when you're using a dictionary style table. Fennel also adds a really interesting feature to basically declare arguments in functions and basically require them. Because in Lua, if you actually don't give a function enough arguments, it won't really tell you that. It will just probably run into a runtime error at some point, and tracing that back can be a lot of headache. And so a lot of times people just go ahead and do arbitrary checking themselves. And Fennel builds this into the language using the lambda keyword, and we'll look into that as well while we work through this program. Like other Lisps, Fennel also adds macros, which are really nice for configuration, which is where Lua is used a lot of the time, is for configuring programs. And so because of that, you can take advantage of macros in order to simplify and compact down repeated code. And finally, it has a really active, positive, and fun-loving community. It's not the biggest community, obviously, but I think a lot of the people in it are just very passionate, and I think it has a pretty promising future when it comes to cool things coming out of it that I wouldn't expect to have seen. Fennel offers a variety of different ways to install it. You can install it with an install script, an actual binary, or using a package manager such as Luarocks, which is what the docs recommend and what I would probably recommend if you're interested in Fennel and Lua in the future. Now, if you guys are interested in Fennel and just kind of want to play around with it, so if you go to the website, right down here, you can start typing in some Fennel code. So if I just did print hello, it will print hello for me. Pretty simple and straightforward, and it kind of gives you a pretty good introduction to the language, which might help you out after this video. So go ahead and give that a try if that interests you. So as I said before, I'm going to go ahead and do this using Luarocks, so you guys can go ahead and give this a try. So if you're on Linux, you're going to want to install Luarocks through your package manager. I'm just going to do pacman luarocks -s. And I already have it installed, so I won't be installing it again. I won't make you guys sit through that. But once you guys have it installed, it's pretty straightforward from there. What you're going to do is you're going to run luarocks --local to tell it to be installed locally. Then you're going to install, and then you're going to do Fennel. Now, when you do local, it's basically saying that you want to have it installed locally, so don't install it to your actual root system, so that way it's system-wide. This way you won't need root privileges, and it's all around just probably the better option. Now, when you do that, by default, it will be in .luarocks /bin. And then if you cd there and do an ls, you'll see Fennel is there. So you can add that to your path, just doing export Luarocks bin, or you can actually do, instead of that, you can do path --bin. And this will give you the path to the bin directory. This is just another way to do it. If, say, for example, you want to make it work on different systems where maybe this isn't the actual default directory, that's another option. And you can actually change this directory from being in your home directory a bunch of different ways. You can take a look at it in the actual docs for Luarocks, but this isn't really a video about Luarocks, so we won't dwell on this for too long. That's all I'll cover for now when it comes to installing Fennel on your system. Note, like I said before, that you can actually use a Fennel.lua library inside of maybe an extension or a script where you want to have Fennel embedded within your program. But for now, we'll actually be doing a much more simple process, which is just compiling Fennel into Lua, which actually has better performance anyways, so there's a benefit there. Now, the docs themselves go a bunch into the different extensions that you can use to add syntax support and such to different text editors. But in our case, I'm going to keep things simple, and we'll just be using the closure syntax highlighting that comes with Neovim just to kind of simplify the process and get you guys started without actually having to install any extensions. So in this video, I'll be using Neovim 5. So in this video, I'm just going to go ahead and get started using Neovim 0.5 in its beta, I believe. but I will try and make this as backwards compatible as possible so you guys don't have to really worry about it. If you aren't used to using Neovim, don't worry. I'll tell you when this stuff doesn't really matter and when you can start understanding things even if you don't use Neovim yourself. So just to get started, I'm going to move my .config nvim to config nvim dash. So now I'm starting scratch. So we can do make dir nvim. And if I cd into nvim, there is nothing in here. All right. So now if I just opened Neovim, it will tell you, as I said before, I'm using the developer version of 0.5, but I'll try and make this compatible. So this is a bare bones version of Vim. Now, what I'm going to go ahead and do is we're just going to go ahead and actually get started. So we're just going to make a directory plugin. And there's a bunch of different ways that you guys could do this to get it to load things, but we're just going to start out really simple and just make it as a local little feature that we can add in. So now if I cd into plugin, and then I can do, we're going to call this showmarks.vim. So we're going to do in Vim. And so now in here, all I'm going to do is I'm going to just do Lua require marks. Lua requires show marks. All right. And we'll just save that. And now I'm just going to cd out of that, and I'm going to make a directory called Lua. All right. And if I just did a tree, you'll see we have our plugin, show marks, Lua. And then I'm just going to do in Vim Lua showmarks.lua. And we'll see show marks not found. Now this is what we're actually creating. It's a show marks, and we're just going to do print hello. Now this, like I said before, is just Lua. We're just getting started, getting you guys into it. So now if I just did nvim, see show marks, module show marks not found. There we go. And then if I did show marks, there we go. Now we're all good. Now we fixed things. So you'll see, so all the issue was that I just had show mark instead of show marks. Now, as you can see, it printed hello when we started up Vim. So that's a pretty good point. If I say Vim in this video, just imagine I'm saying Neovim. It's just a bad habit. But just remember that for the future. So if I say Vim, I'm talking about Neovim unless I specifically clarify. All right. So now if we did a tree, we'll see show marks and show marks. All right. So we've got a pretty good starting point. Now, what we're actually going to do is we're going to make a directory. And instead of calling this one Lua, we're going to go ahead and call this one Fennel. All right, FNL. And so then what we're going to do is we're just going to go ahead and vim nl show marks.fnl. All right. And so in here, what we're going to do is we're going to replicate that. And this is just going to say print hello. All right. So let's just save that. All right. And then what we're going to do now is we're actually going to create a makefile. So makefile. All right. And what we're going to do is we're going to basically give it a way to compile all of our Fennel code into Lua. And really simply, this is just all we're going to do for our makefile. All this is going to do is it's just going to try and create a Lua/make or showmarks.lua, and this will just take anything in the Fennel directory that matches that name, just without the, without the Lua, and it will convert it into Lua code using Fennel right here. Now, alternatively, it has the Fennel script that they tell you to use in the documentation. For now, I'm just going to use what we have installed on our system. You can always switch that around just by doing a // and putting it in this directory, but I'm not going to do that in this case. So now we're just going to go ahead and rm this current version of it because we no longer need what we wrote by hand. Now we can just run make and it will create that. So now if we go ahead and just do vim, we will see that it has compiled it, and we can tell that this is different because it uses return. This is just basically based on how Fennel basically converts to Lua. We can go into this a bit later as we go, but this is basically how you can get started. All right, so we can go ahead and pop open our actual Fennel file. So we're just going to go ahead, lowercase that, and there we go. So we have our Fennel file right here. So now we can run make, and it will actually update the compiled code. So we could go ahead and change this. So let's just go ahead and capitalize this, do hello. All right, let's make that. And now if we just did Lua file, and we just did Lua bam, and it will go ahead and run that. And we can see it did hello Fennel. So now we're able to start compiling things. So now we could do things like maybe we wanted to do something a bit more complicated. Maybe we want to do if, let's just go ahead and go like this. You'll see that the big indicator that I use is these little showing of matches. So now we can do less than 10, 1. So is 1 less than 10? Then do this. And then we can do like a little else print no. Yes. And so now we can save that and let's just make it. And then we can do that Lua file thing again. So if I just go ahead, hit up a couple times, we will see no, 10 is not less than 1. Now, for those of you guys that are a bit confused, you're like, what am I even looking at? Well, let's start from scratch. So in Fennel, like I said before, it is a Lisp. And in Lisp, everything is inside of parentheses, all right? So we have these parentheses right here. And that's why we're doing print. All right, so here we've got the function and its arguments. Now this is equivalent to if we just did this in most other languages. And in fact, this is nearly exactly what it compiles to in Lua. So we can actually go ahead and just reverse this back around, and every argument after it will go in the same sort of way. So if we need another one, like maybe a number or any other argument, they would just all go on as a list. And because of that, it gives it a pretty straightforward way of understanding how everything works. So now let's give you a quick example. Let's add things together. So we're adding 1 and 2 together, right? And if we just make that, we go ahead and source that file, we'll see that it prints out 3. Now this is just taking the function plus, and it is actually taking in the arguments of 1 and 2. Now that's not exactly how it works in Fennel, just because it is compiling this all to a Lua, which doesn't actually have a plus function, but this is the idea of how it works. Same thing with if I did minus and I did make, and then I went ahead and like I did before, just loaded that, it would give us a -1 because it is doing the same thing as if I just did this in most other languages. And this might be a bit confusing for some things, but honestly, it gets pretty straightforward after you've done it a few times. Now, just to give you guys a pretty good example of what sort of types we have here. So we're going to take a 1, and let's just see what type 1 is. We would see that it is a number, and that is the same thing for 1.1. There's no floats and integers for those of you guys that are used to that. So we'll see that this is also a number. Now on top of that, we have strings, and then we'll see that it is a string. Now, strings can be concatenated or put together, in other words, with the ... function, as you can see here. So we're going to do hello world. All right. And this will join them together. So we can actually join as many strings as we want, many as we want. All right. And the ... will actually go ahead and concatenate all these together for us, which is very nice. So that's kind of the general idea of how we can handle strings. There's a few other things that are a bit special about working with Fennel and by proxy Lua. Now, first, we'll go ahead and talk about tables. So for tables, they're pretty straightforward. They're kind of like a combination of a dictionary and an array. So just to give you kind of an example, those of you guys that don't know what a dictionary is, it's basically a bunch of key values. So we'd have 2 and then value 1, 2. And these values and keys could be all kinds of things. So the value could be maybe a 3, and then this could maybe be low. So they don't have to have matching types. So that is the dictionary style table. Now, on top of that, there is also an array style table. You'll notice that in Lua, they like to do just... Now, the difference is the fact that in Fennel, change the surrounding curly braces to square braces. And then we also don't have any commas anywhere really, except for when we're working with macros. So this is a array style table. It's probably pretty familiar with you if you've worked with arrays in general. So this is kind of an array, and we can actually go ahead and pull stuff from it. So let's just go ahead, print. So we're going to go ahead and print from here. If we just printed this table, we'd get a not so great result. So let's just go ahead and save that and make it. If we load that, it will just print table and then a bunch of like hex symbol or something like that. So because of that, it's not super helpful for us, but we can actually use something built into Vim. So vim.inspect, it will actually give you a much better idea of what it is. And this is what it resolves to in Lua, not what it is in Fennel. Keep that in mind. That might be a bit confusing, but it's pretty easy to differentiate. And so if we did the same thing, so let's change these around to a dictionary style thing. So, all right. And so if we just put all that together and then we make that, and then we go ahead and take a look at it, it will print out our dictionary style table. Now that is really awesome and we can get a lot out of it, but we can also, if we just delete this, and instead we want to grab something from it. So let's go ahead and grab a 1. Now how we grab things from a table is we're going to do dot, and this basically says that we're looking at something. So we want to look at 1. All right, so we're going to grab hello out of this is what it should print. Make hello. Now, when I did 1 here, that makes sense because this is the key. And so we want to get the value from the key. Now, you can probably get pretty close to guessing what we're going to do for the other kind. So if we just switch this back to a array style table, we'd probably change this out. And you're probably thinking, oh, we'll use 0 like in every other language. Well, that's actually a trick. Instead, in Lua, for some reason, they decided to start at 1, which I think was a big mistake, but you know what? Could have been worse. And there we go. So now we get hello. Now we can also set something. So we can do tset, and this will set this. And let's go ahead, and that will actually change the values of things. You guys can go ahead and look at tset in the future. So you're probably thinking, why did we call this show marks? What are we exactly going to be doing with this? Well, what we're going to do is we're actually going to do some pretty interesting stuff. So first off, let's go ahead and we're going to create a function. So to create a function, use fn, like I mentioned before, and this is how you go ahead and get started. We're just going to go ahead and actually go set file type to closure, and that should give us a bit extra syntax highlighting just to work with. And then we're going to name the function. So let's go ahead and just call this get mark. All right. And this will, so far, let's just take no arguments for it. And so this is the name of the function, and these are the arguments. So we could do name could be an argument, but we're just going to take none for now. Now, just going ahead, and we can actually take a bit of advantage of some of the Neovim features for accessing Vim from Lua. So what we're going to do is we're going to do Vim, like I did before, to use inspect. So Vim, we're going to use dot, and we're going to use fn, and this allows us to access Vim functions. And dot get marks, I think is what it is. And we can just go ahead and look this up by doing help, and it takes an expression. Now, if we just go ahead and look around, see what the expression can be. If omitted, current buffer is used. All right, so we just want to get the marks from the current buffer, so that's perfect. So we're just going to get marks, and we want to probably store this in something so we can use it later. So what we're going to do that is we're going to use let, all right? And we're just going to surround this in parentheses, all right? And let, we give these square braces, and this is how we can actually temporarily declare things. It's really useful for scoping, like I mentioned before. So we're going to let marks equal these marks. So this is just going to end up being a list, right? And we're just going to go ahead and do vim.inspect marks. All right, and so this should be a pretty good starting point. And then we're just going to do get dash marks to just call it right away. All we have to do to call a function is just put it in parentheses, and it will go ahead and call it. So I think everything is right. We can go ahead and actually just use these little highlighted parentheses to check that everything's right. That looks all good. Let's make it. And then we'll go ahead and try running it. Oh, whoops, no S. That was my issue. Now we've inspected it. Let's just go ahead and print, which is what I meant to originally do, but we won't think about that too much. There we go. All right, now let's go ahead and make, bam. And there we go. Now we have this big long list of all the marks. This is actually not specific to the file, I don't think. I think if it's just left blank, then it doesn't do anything. So I think we actually might have to do, oh, I actually do know how this one works actually. So remember that we have to use double quotes. We can't use single quotes in Fennel. So we're going to use the %sign. So if I did % and I hit tab, it will actually expand to this. So that % will actually expand to the current file. So now if I go ahead and make, then we will see, there we go. Now we're only getting the marks for the current file. Perfect. Now we probably want to go a bit further from here in order to get what I had in mind. So we're going to go ahead and look at the API. And then So I'm just going to give you guys a bit of a background. So what we're going to try and do is we're going to actually look at virtual. And so this is basically what we really want to find is a way to set virtual text. And what we're going to do is we're going to take marks, which is basically, so I can do ML. And then if I do single quote L, it will jump me back there. And so I want to be able to see these marks. So I can do MG and then single quote G, and that will jump me back to it. All right. So you guys can go ahead and take advantage of this however you feel, but this would basically give you little hints on the side right next to the text right over here. And it would kind of just tell us like, oh, this line has this mark, and then we can jump around to it. Kind of a neat idea. I thought of it before this video, and I thought it'd be a cool little idea for a simple extension, and it should be pretty straightforward to implement. So what we're going to probably need, so as we can see up here, is we need a buffer. So let's go ahead and buff. So this will be our buffer. So we're going to need to set that, and we're going to need a namespace goes in the source ID, I think. Yeah, okay. I think that's where it goes. Yeah, namespace ID. All right. So the namespace, so we're going to go NS for namespace, and our namespace will be, well, actually we can just set the namespace to 0 to create a namespace, and then the buff can be 0 to use the current buffer. That's perfect. So these were pretty straightforward, but even though they're both 0, it is nice to be able to have a bit better of variable naming when we're actually using them. If we go ahead and just inspect this again, so we're going to go ahead and save, and we're going to go ahead and show us all of it. We'll see that we have the name of the mark and its position, because I think it's the second one. So let's go ahead and go back, and let's just place a marker. So we're going to do M, and so this is on line 6, as we can see down here. So we're just going to go ahead and evaluate that. G is at line 6 right there. We have our marks. So what we're going to do is we're just going to go ahead and we're going to just list them out next to their line number just to get started. So what we're going to do is we're going to do for each, and then we're going to do iPair. And iPair just basically means that this is not a key value table. It is actually just an array style table. We don't really care about the index of it. What we want is the mark that is in marks. All right, that's a bit confusing, but when you take a look at it for a bit longer, it makes a bit more sense. So we don't, this would be the index. So this would usually be like 1, 2, 3, 4. We don't need that. This will give us the actual mark itself. And so this each here is just iterating through. So iPair right here is basically saying this array style pairing, or this array table, for each pair in there, take the index, which I guess we can just change this to index to make things clear. Take the index and the mark itself. Now the mark is all that we care about. And so we're just going to go ahead and do, so we're going to go ahead and inspect the mark. All right. And there we go. So now we're taking the marks, we're inspecting it, we're printing it for every mark, and then we're letting the marks equal the get marks list sort of thing. And then that is all enclosed in this function, and then we're calling the function. So let's save that. And we are just going to go ahead and quick few corrections. So I did need to add pairs instead of iPair. And I don't know how I missed this, but I needed to add the square brackets for the each. And so there we go. Now when I save it and we do make, this should, there we go. It compiles. Let's see if it actually works now. And if I just do that, then we will see all of the marks as we would expect. Now I wanted to inspect the mark, which is what we're doing for each of the marks. So let's go ahead and just print one of them, I guess. So we could print the mark, and let's print, so we can go ahead and just take a look at the mark, I guess. So we'll just do mark.mark, I believe, is all we would need to do. Now, alternatively, if what we would want to do is maybe we can actually replace that with a dot and then the keyword. All right. And so the dot keyword basically is a way to grab a specific keyword out of there. Alternatively, you can use the dot. This is just a bit of a nicer way to clearly show like I'm grabbing the value from it, rather than the dot syntax, which I think a lot of people associate with Java or C++. Now we need to add an extra parent, as we could see when we checked those. And then now if I did make, that compiles. And let's take a little look at that. There we go. We've got each of the marks. All right, that's perfect. And we're going to concatenate a string. So we have the marks. And then what I want now is I want to get the dot, and then save that, let's make that, and then see if that works. There we go. Now we've got the actual mark and the line number. Perfect. All right, now what we can actually do to simplify this a bit more, so we don't need the index, so we can kind of get rid of that. And then we know the construct of what we want. So now what we can actually do is we can actually do what's called destructuring. So we're gonna go ahead and do that. All right, so this is the general structure of the marks right down here. So now this should make a bit more sense. So if we actually took this and we just kind of put it all on one line, we'll see there's kind of a structure here. And so what we're doing, so this is the actual index, which we don't need to worry about. And then this right here is actually representing this same thing right here. So what we're saying is make this mark value, which is here, and store the string that it contains, the value that this key represents, into mark, and then find the pose keyword, and then take its values. We don't need anything except for the second input, which we are now going to store in the value variable line. And then when I'm saying mark line, that's what I'm doing. So hopefully that's not too complicated. If you're not really used to destructuring, this could seem a bit confusing, which is totally reasonable. I highly recommend getting comfortable with it because it's really powerful and it really simplifies your code and can be very readable as long as you know the structure of what's coming in. And since this is mostly going to be used for me personally, it's not really a big deal. So this is what we've got so far. Now, what we were looking at before was we were looking at help and we wanted to set some virtual text. So we need a line number, which is what this whole thing was kind of about. So what we're going to do is we're going to do vim.api. This is how we access the API. Nvim buff, and then set virtual text. And then we need the buffer. So we're going to do buff. And then we need the source ID, which I think was the namespace. And then we need the line. And then we need, so we want to add mark. And then we need to add the line. So we've got the buffer, the namespace, the line, and then the chunks, and then it also needs a highlight group. Warning message, yeah, let's use that. And so if I just do insert and add that, that should work. And then ops is not used. I don't think we actually need to include that. Okay, let's find out if this worked, because I don't know. This might be a bit too easy. Let's see here. That was totally my fault. There you go. I just needed to remove the commas, because for whatever reason, I think I just mixed myself up when I was looking at the docs. I added them. Happens. Luckily, the error messages are pretty clear when you see them. So expected 5 arguments. So I just leave this empty, I guess. And then this is kind of the one thing that does suck, is that a lot of times you have to go to the Lua to actually go to the actual line number, and then expected Lua table. Oh, I see. I think this is just supposed to be that, and let's make that. Let's close that up. Make, and then it's not an array. Wait, what is it then? Oh, interesting. So it looks like I misunderstood. I think I just wrapped this in another one because it's a list. It looks like it's just supposed to be a list of these little short arrays for some reason instead of using a dictionary. It seems like this sort of, well, I guess that makes sense. Kind of, because it's supposed to be like the text that goes there and then the highlight group. Anyways, doesn't really matter. Now when we execute it, bam, look at that. Look at that. Now we have our marks visible. I think I'm going to call it there. That's been enough time. I think this should have been a pretty good introduction, and you guys can kind of see how you can get started. Pretty much anything that uses Lua, you can start doing this with, because it's like a pretty simple, straightforward approach to things. As long as there's a location where the Lua code goes, you just make the Fennel code compile to it with a makefile. Obviously, there's different ways to approach this, but this is a very straightforward option. I know that I didn't get to go very deep into the actual concepts and working a bit further with Fennel and seeing all the really cool things you can do with it, but that's kind of because it would be very difficult to cover, assuming that you guys don't know any Lua and have little Lisp support. I think getting started is a pretty good thing to just start off really simple and just start playing around with things. If you guys have any questions, feel free to contact me. Join my Discord. I'm very happy to help out. There's a super active community on Matrix. Everybody there is super friendly. If you like IRC, the IRC is also very friendly. It's the exact same group of people, so feel free to give it a look. Really interesting stuff. I definitely will be working with Fennel more and more in the future because I find it really fun to work with. Anyways, guys, I hope you enjoyed the video, and I hope to see you next time. And before I say goodbye, I just wanted to thank my supporters on GitHub sponsors, DFDX and Brian Jenks. Thank you guys so much for supporting me. If you guys want to support me, go ahead and hit me up on GitHub sponsors or on Patreon. I'm always happy to just have you guys chat too. So feel free to swing by the Discord and chat with everybody. We're always happy to talk. Anyways, see you guys around. Have a great day, and I hope to see you guys soon.